Hello, I am Krishna Kumar, Assistant Professor from EEE Department, Vidya Academy of Science and Technology. I am going to take a new subject for you, Signals and Systems, in your 5th semester. The subject name is Signals and Systems and subject code is EE307. So, introduction to signals. This is the beginning of first module of Signals and Systems. This is the beginning of first module of our subject Signals and System. That means introduction to signals. What is meant by a signal? Anything that carries information is known as signal. Anything that carries information is known as signal. Signal is a physical quantity, varies with the time, space or any other independent variables. A signal is a physical quantity varies with the time, space or any other independent variables. Anything that carries information is known as signal. Signal is a physical quantity, varies with the time, space or any other independent variable. Okay. Signals are of different types. Signals are of different types. One-dimensional signal, two-dimensional signal, three-dimensional signal, etc. Or in other words, we can broadly classify the signals into one-dimensional signals or multi-dimensional signals. I am repeating, signal is anything that carries information is known as signal. Anything that carries information is known as signal. Signal is a physical quantity, varies with the time, space or any other independent variables. Signals are broadly classified into two, one-dimensional signal or multi-dimensional signal. Multi-dimensional signal includes a two-dimensional signal, three-dimensional signal, etc. Okay, so signals are variables that carry information. It is described as a function of one or more independent variables. Basically, it is a physical quantity. It varies with some independent or dependent variables. Signals can be one-dimensional or multi-dimensional signal. Okay. Say a function signal, the more explanation about signals. A function of one or more variables that convey information on the nature of a physical phenomenon. So examples for signals are V of t, voltage, V of t, I of t, X of t, heartbeat, blood pressure, temperature, vibration. All these are signal. I told you that what is meant by signal? Anything that carries information is known as signal. So different types of signals are voltage, current, then V of t, I of t, then X of t, heartbeat, blood pressure, temperature, vibration. All these are signals because all these give us some important informations. Signals are classified into one-dimensional signal and multi-dimensional signal. If a signal depends only on one variable, it is called a one-dimensional signal. If a signal depends on two variables, it is called a two-dimensional signal. If a signal depends on three variables, it is known as three-dimensional signal. That means if a signal depends more than one variable, it is known as a multi-dimensional signal. Speech signal is an example for one-dimensional signal, whereas image is an example for multi-dimensional signal. Speech signal is an example for one-dimensional signal, whereas image is an example for multi-dimensional signal that we can discuss later. So different classification of the signals are broadly classified into one-dimensional signal and multi-dimensional signal. Then another classification of signals. Different types of signals are specific classifications. Broad classification is one-dimensional and two-dimensional. Depends on so many other factors. We can classify the signals like this. Difference of so many other factors. We can classify the signals like this. Classification of signals. Continuous time signal and discrete time signal that we are going to study first. Continuous time signal and discrete time signal, periodic and non-periodic signals, causal and non-causal signals, deterministic and random signals, even and odd signals, energy and power signals, etc. So we can discuss all these signals one by one. I am repeating, the broad classification of signals are one-dimensional signal and a multi-dimensional signal. Anything that carries information is known as signal. Signal is a physical quantity that varies with the time, space or any other independent variable. These are the two definitions that you have to study by heart in this subject. What is meant by signal? Signal has two definitions. Anything that carries information is known as signal. Signal is a physical quantity, varies with the time, space or any other independent variables. If a signal depends on one variable, it is called a one-dimensional signal. If a signal depends more than one variable, it is called a multi-dimensional signal. So speech signal is an example for one-dimensional signal, whereas image is an example for multi-dimensional signal. These are the things we covered till now. Then another classification of signals depends on so many other factors. We can classify the signal like this: continuous time signal and discrete time signal, periodic and non-periodic signals, causal and non-causal signals, deterministic and random signals, even and odd signals, etc. Then first one we are going to concentrate: continuous time signal and discrete time signal, CT and DT signal. From the name itself you can understand the nature of these two signals. Continuous time, in the latter one discrete time. So what is the difference between these two? In the first one time is in continuous, whereas in the second one time is in discrete. It is defined at a specific instance of time. That is the major difference between continuous time signal and discrete time signal. CT signals, that means continuous time signals, take on real or complex values as a function of an independent variable that ranges on the real numbers denoted as x of t. So time is on x-axis, x of t is on y-axis. So these time is defined at all instance of time. That is the main feature of important feature of continuous time signal. CT signals take on real or complex values as a function of an independent variable that ranges over the real numbers denoted as x of t. Whereas in the case of discrete time signals, the only difference is discrete time signals take on real or complex values as a function of independent variable that ranges over the integers and denoted as x of n. Okay, that means in the case of continuous time signal, t is on x-axis, x of t is on y-axis. It is defined at any instance of time. Whereas in the second case, discrete time signal, n is on x-axis, because time is defined at a specific instance of time, not at all time. That is the main difference between continuous time signal and a discrete time signal. Continuous time signal can be represented as t versus x of t. Discrete time signal is represented as n versus x of n. Okay, in a continuous time signal, t versus x of t. T is on x-axis, x of t is on y-axis. In the case of discrete time signal, n is on x-axis, x of n is on y-axis. The main difference between continuous time signal and discrete time signal is in a continuous time signal, time is defined at every instance of time, whereas in the case of discrete time signal, time is defined at a specific instance of time. Time is not continuous. In a discrete time signal, time is in discrete. Time is defined at a specific instance of time. While we are drawing a discrete time signal, n is on x-axis, x of n is on y-axis. While we are drawing a continuous time signal, t is on x-axis, x of t is on y-axis. Okay, that is the difference between continuous time signal and discrete time signal. So we can concentrate more, we can study more about continuous time signal and discrete time signal. So continuous time signal is defined at the difference between continuous time signal and discrete time signal. It is defined at every values of time. Whereas discrete time signal is defined at a specific instance of time. That is the main difference between continuous time signal and discrete time signal. Continuous time signal takes all possible values of amplitude. So amplitude is on y-axis. Here look at the graph. Continuous time signal, a voltage signal is drawn as a continuous time signal. On the right hand side, the same voltage signal is drawn as the discrete time signal. T versus x of t. Here x of t is equal to v or v of t. In the case of discrete time signal, n versus v of n. Okay, so it takes all possible values of amplitude. Amplitude is on y-axis. Time is on x-axis, amplitude is on y-axis. It takes all possible values of amplitude. What about discrete time signal? It takes a finite set of amplitude values. There is no continuity in the amplitudes. There is a continuity in the amplitudes in the case of continuous time signal, but in the discrete time signals, it takes a finite set of amplitude values. For each corresponding finite instance of time, there is a finite value of amplitude. So amplitude is not continuous in time, as in the case of continuous time signal, amplitude is continuous. It takes all possible values of amplitude, whereas in the case of discrete time signal, it takes a finite set of amplitude values. That means in the case of y-axis, amplitude is not continuous. It has a finite set of amplitude values. Look at one example. Draw a CT signal. Draw a continuous time signal x of t is equal to e raised to 2t. It's an exponential signal. Draw a continuous time signal x of t is equal to e raised to 2t, where t varies between minus 2 to 2. Because we are going to draw a continuous time signal, time is on x-axis, small letter t is on x-axis, x of t is on y-axis. Because our signal is a continuous and it is a continuous time signal, it is continuous in both x-axis and y-axis. That means x-axis time, y-axis amplitude. How can we draw this continuous time signal? We can check. The given signal x of t is equal to e raised to 2t. The allowed values of small letter t is from minus 2 to plus 2. That means minus 2, minus 1, 0, 1, 2, etc. Not etc. Minus 2 to plus 2. Minus 2, minus 1, 0, 1, 2. So first of all, we can find all these values one by one. How? X of t is equal to e raised to 2t. Then x of minus 2 is equal to. Substitute the value of t is equal to minus 2. Substitute the value of t is equal to minus 2, because we are going to calculate x of minus 2 is equal to e raised to 2t is equal to e raised to 2 into minus 2 is equal to e raised to minus 4 is equal to 0.0183. In the same manner, you can find out x of minus 1 is equal to e raised to 2 into minus 1 is equal to e raised to minus 2. In the same manner, you can find out x of 0 is equal to e raised to 0. X of 1 is equal to e raised to 1. X of 1 is equal to e raised to 2 into 1 is equal to e raised to 2. X of 2 is equal to e raised to 2 into 2 is equal to e raised to 4. In the same manner, you can find out x of minus 2, x of minus 1, x of 0, x of 1, x of 2, and you will get different values. After that, take t is on x-axis and take these x of t is on y-axis. You can draw a simple continuous time signal x of t. Okay. So another example, sketch the signal x of t is equal to e raised to minus t, where t varies between 0 and 2. T is in 0 less than or equal to, t less than or equal to 2 means t varies between 0 and 2. Sample the signal with the t is equal to 0.2 seconds. Sample the signal means you have to sample the signal, means the sampled signal is discrete time signal. The given signal is continuous time signal. The given signal is continuous time signal. The sampled signal is discrete time signal. So we have to draw both signals as far as this problem is concerned. Sketch the signal x of t is equal to e raised to minus t, which is a continuous time signal. So first of all, we have to draw this continuous time signal. After that, we have to sample it. After sampling, we can draw it as a discrete time signal. The first one is continuous time signal. X of t is equal to e raised to minus t, where x of t is equal to e raised to minus t for 0 less than or equal to, t less than or equal to 2. So the values of t's are 0, 0.5, 1, 1.52. Or you can take a 0, 1, 2. No need to take the point values. No need to take the decimal values. Okay. You can take any values between 0 and 2 in the case of continuous time system. In the case of discrete time system, you are not allowed to take all the values. You have to take the values at a specific instance of time. In this case, the allowed values of small letter t is in between 0 and 2. You can take it as 0, 1 and 2. Or you can take a 0, 0.5, 1, 1.52. Or you can take it as 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8 to 2. Because this is a continuous time signal, you are allowed to take all possible values of time between 0 and 2. You are allowed to take all possible values of time between 0 and 2. I am taking 0, 0.5, 1, 1.5 and 2 between 0 and 2 in this problem. So how we have to calculate x of 0, x of 0.5, x of 1, x of 1.5, x of 2, etc. Not etc, x of 2. Then first one, x of 0. X of 0 is equal to e raised to minus t is equal to e raised to minus 0 is equal to 1. The next one, x of 0.5 is equal to e raised to minus into, substitute the value of minus 0.5 for t, e raised to minus 0.5. You can calculate this value. You can calculate e raised to minus 0.5 in your calculator. By using calculator, you have to calculate all these exponential values. E raised to minus 0.5 is equal to 0.606. Then x of 1 is equal to, substitute the value of 1 for small letter t is equal to e raised to minus 1 is equal to 0.367. Then x of 1.5 is equal to, Substitute the value of 1.5 for t e raised to minus 1.5 is equal to 0.223. Then x of 2 is equal to e raised to minus 2 is equal to 0.135. 0.135. Thus we got x0, x of 0.5, x of 1, x of 1.5, x of 2. So take t is on x-axis 0, 0.5, 1, 1.5 to 2.5 is on x-axis, and the amplitudes are on y-axis x of t versus x of t. At 0, x0 is equal to 1. At 0.5 its value is 0.606. At 1 its value is 0.367. At 1.5 the x of t is 0.223, and x of 2 is equal to, at t is equal to 2, x of t is equal to 0.135. So just mark out all these points and just join all these points. Thus you will get a continuous time signal. So the first part of this problem is over. How can we draw a continuous time signal? Simply substitute the values for different values of t between the allowed time period and find out the corresponding x of t values. So take t is on x-axis and x of t is on y-axis. Mark out all these points. Just join these points. Thus you will get a continuous time signal. So you can draw any type of continuous time signal by using this method. I think this method is very clear. Okay. The next part of this problem, the problem is not over. We have to sample the signal and then we can draw a discrete time signal that we are going to do next. For a discrete time, how can we draw a discrete time signal? How can we sample this signal? So in the case of discrete time signal, it is defined at a specific instance of time, not at all time. Okay, it takes a finite set of amplitude values. It doesn't take all possible values of amplitude. It takes a finite set of amplitude values. So how can we sample that? We are going to discuss first. For a discrete time signal, n versus x of n. N is on x-axis, x of n is on y-axis. So x of n is equal to x of t at t is equal to nt. That means substitute the value of n, capital letter T is the fundamental time period. Fundamental time period means the period at which we are going to take the samples is known as time period. The period at which we are taking the samples at a specific interval, that interval is known as t. So x of t is equal to x of n is equal to x of t at t is equal to nt, where t is the time period. At that particular period we are going to take the samples. When we substitute nt at t, we will get x of nt, x of n capital T. Small letter t and capital T are different. Small letter t indicates time, capital letter T indicates time period. We are taking the samples at different time periods, at a specific time period represented as capital letter T, not different time period, a specific period. We are taking the samples at a specific interval of time. That interval of time is known as time period capital T. So x of n is equal to x of t at t is equal to nt, which is equal to x of nt and capital T. Don't confuse between small letter t and capital T. Small letter t means time, capital T is the time period at which we are taking the samples. Both are different. So how can we find out x of n? We know that x of t is equal to e raised to t. How can we find out x of n? We can calculate x of n is equal to x of t at t is equal to nt. That means substitute n capital T for small t. Substitute n capital T for small t. That means x of n is equal to x of t at small letter t is equal to n capital T. That means e raised to minus t at small letter t is equal to n capital T. That means e raised to minus nt, അതായത് സ്മോൾ ലെറ്റർ ടിക്ക് അവിടെ ക്യാപിറ്റൽ എൻ ടി എന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക, സ്മോൾ ലെറ്റർ ടിക്ക് അവിടെ എൻ ക്യാപിറ്റൽ ടി എന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. ദസ് യു വിൽ ഗെറ്റ് ഇ റൈസ് ടു മൈനസ് എൻ ക്യാപിറ്റൽ ടി. ദസ് വി ഗെറ്റ് എക്സ് ഓഫ് ടി ഇസ് ഈക്വൽ ടു ഇ റൈസ് ടു മൈനസ് ടി. എക്സ് ഓഫ് എൻ ഇസ് ഈക്വൽ ടു നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു, ടിക്ക് എൻ ക്യാപിറ്റൽ ടി എന്ന് ഇ റൈസ് ടു മൈനസ് ടി അല്ല ടിക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തു. അപ്പോൾ ദസ് വി വിൽ ഗെറ്റ് ഇ റൈസ് ടു മൈനസ് എൻ ക്യാപിറ്റൽ ടി, ഇ റൈസ് ടു മൈനസ് എൻ ക്യാപിറ്റൽ ടി. ദസ് വി ഗോട്ട് എക്സ് ഓഫ് എൻ ഇസ് ഈക്വൽ ടു ഇ റൈസ് ടു മൈനസ് എൻ ക്യാപിറ്റൽ ടി. Thus we can simply calculate different values of n, x of 0, x of 1, x of 2, x of 3, etc. Okay. So we are taking different samples. So x of 0 is equal to e raised to minus n into x of n. Substitute the value of 0 for n. Up e raised to minus nt, e raised to minus 0 into t is equal to e raised to minus 0 is equal to 1. X of 1 is equal to x of 1. Substitute the value of 1 for n. Up e raised to minus 1 into t. The value of capital T is given in the problem. The value of capital T is given in the problem, which is nothing but 0.2. 0.2 second is the capital T. The value of capital T is given in the problem. Then only we can calculate this. So just like the problem, sketch the signal x of t is equal to e raised to minus t for 0 less than or equal to t less than or equal to 2. Sample the signal with the t is equal to 0.2 seconds. At this particular time interval, we are going to take the samples. At every 0.2 second, we are taking the samples. The value of capital T is given. The value of capital T is given. So first of all, we are taking x of 0. X of 0 is equal to e raised to minus 0 is equal to 1. X of 1 is equal to e raised to minus 1 into 0.2. Capital T is given in the problem. Capital T is the time period. E raised to minus 1 into 0.2. Thus we get e raised to minus 1 into 0.2 means e raised to minus 0.2. Thus we will get a 0.818. By using calculator, you can easily calculate these values. In the same manner, x of 2 is equal to e raised to minus 2 into 0.2 because capital T is equal to 0.2, which is given in the problem. X of 2 is equal to 0.67. Similarly, x of 3 is equal to e raised to minus 3 into 0.2. Capital T is always fixed. That period is always capital capital T. That means time period is always fixed in this problem. In every problem, capital T is always fixed. The value of n is changing. Why we are calculating x of 6, the value of n is 6. X of 7, the value of small letter n is equal to 7. X of 8, the value of n is equal to 8. So we can calculate x0, x1, x2, x3, x4, x5, x6, etc. So we are taking the values of n. There is no specific limitations for the values of n. Okay, so we can calculate some values. We are taking values. We are taking the values of n is on x-axis. We are taking the values of x of n is on y-axis. We got different values of n and corresponding x of n. So simply mark out all these points. So don't draw it as a continuous curve. This is a discrete time signal. It is defined at a specific instance of time. So the value of x0 is equal to 1. The value of x of 1 is equal to 0.818. The value of x of 2 is equal to 0.67. And just simply draw a line at these specific intervals. So this is the discrete time signal. It is defined at a specific instance of time, not continuous in time. It has a finite set of amplitude values. It has a finite set of y-axis values. Okay, that is the main difference between discrete time signal and continuous time signal. If you are given a signal, definitely you can sketch a continuous time signal and a discrete time signal. Before drawing the discrete time signal, first of all you have to sample it. How can we sample? X of n is equal to x of t at t is equal to n capital T. X of n is equal to x of t at t is equal to n capital T, where t is the fundamental time period which should be given in the problem. Then only we can draw the discrete time signal. I think the continuous time signal and discrete time signal is clear. So what is meant by signal? Our subject is signals and systems. Subject code is EE307. We are starting our first module. Anything that carries information is known as signal. Signal is a physical quantity varies with the time, space or any other independent variable. If a signal depends on one variable, it is called a one-dimensional signal. If a signal depends on more than one variable, it is called a multi-dimensional signal. Speech signal is example for one-dimensional signal. Image is an example for multi-dimensional signal. So we can broadly classify the signals as one-dimensional signal and a multi-dimensional signal. What about other classifications? These classifications based on so many other criteria, so many other factors. The first different classifications of signals are continuous time signal and discrete time signal, periodic and non-periodic signal, causal and non-causal signal, deterministic and non-deterministic signal, energy signal and power signal, etc. So these classification based on some important factors. The other classification is the broad classification. We can broadly classify the signal as one-dimensional signal and a multi-dimensional signal. Then first one is the next classification is classification of signals based on some important criteria or important factors. Among these, the first one is continuous time signal and discrete time signal. How can we differentiate between these two signals? From the name itself, as the name implies, we can understand that continuous time signal is continuous in time, discrete time signal is discrete in time. The main difference between continuous time signal and discrete time signal is continuous time signal is it is defined at all instance of time, whereas discrete time signal is defined at a discrete instance of time. In the case of continuous time signal, it takes all possible values of amplitude. Amplitude is on y-axis. Whereas in the case of discrete time signal, it takes a finite set of amplitude values. Clear? Then in the next part we studied how can we draw a discrete time signal and a continuous time signal. A continuous time signal is given. For example, x of t is equal to e raised to minus t. The allowed values of t should be given in the problem. Then only we can draw a continuous time signal. So t is on x-axis, x of t is on y-axis. So calculate x of t for different values of t in the allowed time period. Then simply mark t is on x-axis, x of t is on y-axis. Just join out these points, then you will get a continuous time signal. For drawing a discrete time signal, first of all you have to sample the continuous time signal first. How? X of n is equal to x of t at t is equal to nt, and capital T, where capital T is the time period which should be given in the problem. So first of all calculate x of t, x of n is equal to x of t at t is equal to nt, that means x of nt. Then calculate x of n for different values of n and mark out all these points, just to draw lines at specific intervals of time. Thus we will get a discrete time signal. So in this manner you can draw any types of continuous time signal and discrete time signal. Okay.